Hello, everyone. In the last video, we talked about the different functions on dplyr that we can use to actually interact with our data and either make it a smaller data set or make new variables. And in this video, we're going to be talking about what to do when you have multiple data sets or data tables, files of um, of the same individuals of a study, like the same patients, let's say, but they're in different files, and we want to join them together. So in this video, we're gonna go over the different functions that are actually also in the dplyr package, and when you might want to use uh, each different function. So, so the first thing we're going to do is bring the files into our working directory so that we can upload them easily onto R and into our environment, which, just a reminder, is this side here, which keeps track of all the files that are currently on R. So to do that, we will bring up the files. So we're going to take our folder, which has the different data sets that all have different data, but of the same patients. And we're going to drag that into our working directory. So that, and we'll put that into this folder, and now we have it in our working directory. So let's go back into R, and we're gonna do another open up another R script file. So in, like I said from the last video, and whenever you're doing a script, you're going to load in all of the packages that you want to use in that session. So we're going to do tidyverse. And I think for this one, that should be the only one we really need. Let's save this and do joining data. So we need we need a tidyverse. We don't really need any other functions as of now, but if it comes up, I'll add them to the top. So just to stay consistent, I'm gonna keep track of all the sections of the code by putting in these comments. So data loading, reading, and data. So we're gonna do, so let's check the files that we have. So we're gonna have to read in each data set to the baseline, and we use read underscore CSV, and then we're gonna do the name of the folder that's in the working directory. So it's data to join, and then we have to actually say the file that we want to assign to this object. So it's baseline underscore QLESQ.CSV, and then run that, and now we have this data set, which is the baseline data for this variable called QLESQ. And now we're going to do the same for the rest of the data sets. So just copy and paste. Well, name will be demographic, so let's name it demo. And we'll keep the folder because it's in the same folder. And the only thing that's different is the first part of the file name, so demo graphics. All right, there we go. This one just has the demographic information on each person in the study, and the ID is an identifier for that person's for that specific person. So instead of having their name, you have a number. You assign them a number at the beginning of a study. So these are the instead of having the patient's name, we have these ID numbers, and we also have some here. However, we don't have the same amount. Here we have goes up to 20, 1 to 20. This one only goes up to 15, and we don't have every single number. So that's going to pose a problem that we'll go over. Lastly, let's do follow-up. And one thing we're going to change is the first part of the name. And we have this one as well, which has the ID number, and it also has the follow-up QLESQ value for each observation, each patient. Now we have that. We can open up, and we have them opened up, and you can see that not all the data sets have the same have the data for each individual participant. You can see here the demo has all of them. It goes every number from 1 to 20. And for baseline, we have some missing. We're missing 6, we're missing 8. And then in the follow-up data, we're missing 1, 3, 4, missing a bunch. We only have 10 out of 20. So there's different ways that we can join these these data sets together. And we can either decide to keep every single observation, every single patient's information in, or we can only do, we could only include observations or rows of patients that have, like, let's say they have follow-up data, or they had baseline, didn't have follow-up. As long as they have baseline, we'll include them. Or we could do only if they had follow-up. So the way we do that is by using the join function, like set, and there are there's 4 different types of join functions. There's full join, left join, right join, and inner join, and I'll go through all of them. So let's just do the most simple one first. That's full join. And when you full join data sets, you're including every single one that's in so basically if it shows up, if a observation shows up in a data set, it's going to be in the final one. So here we have like 1 through 20. And sorry, this one's 1 through 20. So 17. So you can see here, there's 1 in 17, but 17 wasn't in the follow-up or in the baseline. But because we're doing a full join, it's going to show up because there's at least one of them. And that goes for all of these observations. So the way we do this is, let's just name it full join. And we're going to do the function is full join. And the way you write this is you write every single, the name of the storage objects of each data set. So we'll do baseline, demo, follow-up, and each one is separated by a comma. And then we're going to include the argument by, which is the variable with which you want to match the data sets side by side. So like so that the values for, like, let's say like 2 this value here is going to be added to this row, and this value here is going to be added to this row. Basically, just make sure that each respective patient's data is correctly placed on their row in a data table. So the thing that's similar amongst each table is the ID number. So we're going to do by and set it equal to ID. And it's going to be in parentheses the name of the key, which is the value with which you're combining them by. So we'll do full join. We'll do full joined. What we'll see is that let's organize by ID. So what you see is that this only, oh, okay, I made a mistake. So we need to do this twice actually. If you're going to be doing more than one, if you're going to be adding more than one data set together, you actually have to do multiple joins, one after the next. So full join, if I just did this, it was baseline and demo. So currently it only has, it combined all the baseline data with all of the demo data. But whenever there is baseline data that didn't have a value for that ID, it just filled it in with an NA. So now we'll do another full join. We'll do this twice, and we'll just do, I believe we don't have to write all of them again. We just do the next one that's going to be added. So we'll do, since we already have baseline and demo together, and we're going to use a pipe, and if what you remember is and then. So we join we full join these two data sets, and then we're going to full join that with the follow-up. And just make sure that you include the key, which is the ID in this one, which we're going to be merging them by or joining them by. So we'll do that again. And now full joined has all of the both data sets involved are included, and regardless of if it kept every single observation, every single patient data, regardless of if it had a value for the baseline of the follow-up. As long as it was in one of them, they would be included in the final data set. So now let's say you don't want that. Let's say you're doing this research and it would be meaningless if they don't have a baseline reading. So what you would do is instead of doing a full join, you would do a more specific join. So one thing you could do is just use you'd use either a right join or a left join, which are just more like they're more selective on what they include. So, and that the like name left versus right just it just is it relates to where in this statement you put them. So this is the left position, this is the right position, and left join. It will only include observations that have a value and have all values in this position, in this like a positions data set. But if it doesn't have like certain values from this one, it's just going to drop them. And I could show that here. I'm just doing left join. So left join. So we'll do left join. So let's say with what we said, we only want data that has, we only want to have like patient data that has a baseline reading. So we'll do baseline demo by still equal to ID. So we run that. And now when we look, we only have the if you compare this to the the baseline, you'll see that we only have in this new data set, we'll only have the patient data and observations of those who were in uh, the baseline data set. So see, they both have 15 rows because they only have 15 observations, and they kicked out the 5 observations that were in here that were not in baseline. So now, if you did that with the right joined, you'd have only the ones that were included in demo. So it's basically so now we can do right join, but we'll do it with just so I can show you how it works. We'll do right joined, and now we'll do the left joined one. We'll use this new object that only has the things that were in baseline. And so we'll do left joined, which has demographic and baseline information on only those that had baseline readings. And then we'll do follow up by equals ID. And this means that now of those people that had baseline data, this right joined data set object will only have those that also have follow-up data. So we'll run that. This should be right join, not right join. And now we have right join, which has baseline data, has follow-up data, and it has demographic data, but it does not, but it only has those that had that had both baseline and follow-up data. And I believe there's a quicker way to do this, but I don't know if it makes sense to show it in this way. But there's one more type of join that is important to know about, and it's the inner join. And an inner join is when you make the new data set that you're making only has observations that are in both that have data in both data sets that you have. So we'll do inner join. And then we'll do inner join. We'll do inner join. So let's only make a data set that has the demographic data and also has then that has demographic data and has follow-up data. So it doesn't matter which order we put it because it's gonna include only the ones that are in both. So we'll do baseline. So we'll do follow up and demo, and we're gonna do by is equal to ID. Run it, and you can see inner joined. It has follow-up data, it has the demographic data, but you'll see that it only has, because in this case, demo has every single one, it only has the ones that are in follow-up because it has to be in both. And you won't have any missing values in this case because because that's just the way the function happens. Like if you have any NA value when combining them, it's just going to delete them. And I just want to reiterate that when you're working with this data, that you can't combine more than two at a time when you're using these join functions. So you need to break it up and first make one a new like a join make one joined data set, and then you pipe it into the next one. If you have three or more data sets that you want to include together. So now that's it with the actual like coding aspect of it, but I want to see if I can just show like maybe graphics that could help. This is from notes that I have from the class that I took, and basically it shows, maybe the Venn diagram would be the best description of it. Okay, so this just shows you the data that is included in each type of join. So imagine that each circle represents the complete data in one, and so the one on the left is the complete data in X, the X data set, and the circle on the right is the complete data in the Y data set. So when you do an inner join, the only data, and the shaded is what is kept in the new data set that you make. So the inner join will keep the data, only keeps data that has the complete observations that are both in X and in Y. Left join, if we're saying X is on the left, will only keep observations that are in X, and if Y has those observations, it will also be included. But if Y has observations that were not in X, or like patient data that was not in X, then it will be excluded. Full join will include data. The new set will have all the data, regardless of if it's in one versus the other. And the right join will only keep observations that X has that Y also had. So I hope I didn't confuse you by including this or by the way I taught it, but it is useful. These are useful functions to have when you have multiple types of data and you're getting them from different sources. Yeah, like it's quite useful, and I hope it was helpful. And in the next video, I believe we're going to let's see, we're going to be doing some just kind of descriptive analysis, kind of similar to the summarize function, but it's a good way to make like data tables that you see in like we're gonna learn how to make like data tables that you see on a post presentation or maybe even like a paper. So thank you for watching this video.